Hello, this is the final part of fast implementation of USB-MIDI converter to the NUCLEO board based on uh, STM32 411, and I already connected my stuff to my laptop, and you see that I already connected the LED board to the NUCLEO board. These LEDs will be used for indicating node on and node off events for indicated playing nodes. Let's go to our CubeMix project, and we have 4 LEDs that are connected to selected pins. We selected PB3, PB4, PC2 and PC3 as output for LED functionality. And let's go to IDE again, and let's see what I added additionally to my previous code. At first, let's remember that in previous videos we added our own USB-MIDI related descriptors, and also I implemented the basic handler for input USB-MIDI packets. In this handler I only set the specific flag that I described as USB-MIDI received. This is a global variable that will be set in 0 after each startup of MCU. Okay, when we receive some data from a USB port, we can process this data, checking this flag. Let's go to main C, and I added this flag as extern int variable to my main C file. Also, I added R buffer as extern variable to my main C. Also, I added some additional definitions to my code, and I will explain them below. And the main thing that I added to my code, this is the main processing function that should be added to main while loop. In this function I check the current MIDI message that was received. At first I check the USB-MIDI received flag, and if it set to not 0, that means that some MIDI packet was received. I continue to process it. After I only reset the USB-MIDI receive flag to 0, and then I continue to check what event. In this example I used only 2 types of events: node on, when we press the specific key on USB-MIDI keyboard, and node off, when we release the specific key. We use rbuffer array to check various parameters, and for better understanding what array contains on specific index, let's look at the USB-MIDI specification document. Zoom in it. This is the USB MIDI specification 1.0, but this table also is valid for 2.0 version. On figure 8 we have the structure of USB MIDI packet that consists of 4 bytes. The first byte contains the cable number value and code index number value that is described below. Also we have 3 bytes with data. In our case, the first byte, byte 1 I mean, will contains the event code. So in our example we have 2 types of event: node on and node off. The byte 2 will contains the node code. This is a specific code for each node. and the byte 3 will contain the velocity value. Briefly, that is all. Let's return to our code. We have 4 nodes, and for each of them I defined the specific key that we will use in our example. In our code we only check the current event and then we turn on or turn off the LED for related key. That is simple. Let's try to test our device. For testing the code, you should use some kind of software that will allow you to communicate with MIDI ports on your PC. For example, I use the USB-3 software, and I will press the corresponding keys to our firmware. Okay, that's good. Let's try to play something. Now let's upload our firmware and test our device. Let's build and let's flash. Okay. Download verified successfully. Let's reconnect. Let's go to device manager and see what we have. So we have MIDI STM32 audio, that is good. Now let's switch to our virtual piano, and from instrument menu I will select the MIDI STM32 audio device. And then let's press the keys. Device is working as well. And as final step, I will try to play Children of Bodom in your face intro. This was the fast approach that I wanted to show you how to implement the USB MIDI interface to your board based on STM32 chip. But there is no matter what chip you use, because all steps are similar. You should implement descriptors related to your USB interface, and also you should to implement your main functions that will process messages from USB. And if you have some questions, please write and ask me. And thanks for watching.